Welcome all of you. This is STEM Academy, TRICHY. We are dealing kinematic sums, motion under constant acceleration. Now we are dive into one interesting sum. A body is projected vertically upward. If T1 and T2 are the times at which it is at height h above the point of projection, while ascending and descending respectively. Find the velocity of projection height and C maximum height reached by the body, maximum height, and C D velocity at height h by 2. Here now I'm going to give you the solution that the problem stated here, the body is projected upward. So body is projected upward, vertically upwards, so against gravity. So when a body is projected upward, the velocity, initial velocity, is considered as u. At time t1 ascending and time t2 descending at the height of h above the point of projection. This is the point of projection. So this is started, and this is height h. This is ascending position. This is descending and reaching here. This starting point. This is reach, end. Clear? This is ground level. So point of projection also, this is the ground level, point of projection. Clear? At the height h, there is time taken. At this ascending position, time taken is t1. At this position, time taken is t1, and descending position, time taken is t2. So during ascending, during descending, this is taken as ascending, A, S, C in ascend position. This is descend position. Descend position, because it is going downwards, going upward. At this moment, going upward. At this moment, downward. Position from the point of projection is h, height. The same position for t1 time and t2 time, ascending state and descending state. For this equation, we need to use kinematic equation. Equation under constant acceleration due to gravity. Here clearly h height, this is h height, h equal to, at the time of point of projection, velocity, initial velocity is u. At the time t1, the position will be h. T1 position, T1 at the time of T1, the position of projection in ascending direction is h minus half g T1 square. Because why it is minus? At the time of starting projection, u is upward and g is downward. So it is anti-parallel vector. So I'm using the same equation present u and g. So use vector sign for initial velocity plus and gravity is minus because anti-parallel vectors. And this is the equation 1, and the second equation is for descending case. This is ascending case. This is the equation. This is the descending. Descending also, the position of height is h, and velocity, initial velocity is u at the time position t2 in descending. Clear? At initial velocity u as positive and minus half g t2 is negative because u at the time of projection u is positive and g is negative. It is upward, it is downward. So use the same sign again, and this is the equation 2, number 2. So those equations, what actually we found here, equation 1 and 2 is state of position is equal, h. Displacement, state of position from the point of projection, the state of the particle in ascending and descending is h height. So same, 1 and 2 is same. So equate each other, and then what I need to find is u t1 minus half g t1 square equal to u t2 minus half g t2 the whole square. Clear? t1 t2. Then u t1 u t2 u t1 minus u t2 equal to half g t1 square. This portion is goes to right side, minus sign will get plus sign, and as it is minus 1 by 2 g t2 will come as it is. So same patterns are segregated and cornered. T1 minus T2. The common factor U is taken out of bracket is equal to half, and G. Half into G is common factor. The remaining will be is as T1 square minus T2 square. Clear? So this is like a property A square minus B square. So expand and here the pattern will cancel both side. G t1 minus t2 t1 plus t2. This is when abbreviating this property t1 minus t2. So when cancelling both side u equal to half g t1 plus t2. Clear? This is the result as a initial velocity, upward velocity u we have. Clear? And u is found here, and we need to find height. We need to find the height. So height equation, either equation 1 or 2 equation, we should choose that equation. H is equal to u t1 minus half g t1 square. So according that here we found u, just paste it, half g t1 plus t2, clear, into t1. This is the u. Clear? This is the u. This is the u. What is that actually? H is equal to half g t1 plus t2 into t1. As u we substitute, and minus half g t1 square. When multiplying inside, half g t1 t2 plus half g t1 square minus half g t1 square. So here we can find the similarities here. So cancel each other. H is equal to half g t1 into t2. Clear? We got what is height. At this height, ascending and a descending position is a mathematical relation we found. Actually, this is what we needed, and the maximum height we need to find. For that maximum height, at the maximum height, the velocity will be 0, because at saturation, gravitation is counter gravity will make the body 0 velocity at maximum height. So when maximum velocity has a general equation v squared equal to u squared plus 2gs. So this is the general equation. For that, u is upward, g is downward at the time of projection. So just u squared minus 2gs for this system is taken like that. So for that, v equal to 0, to get the maximum height, v equal to 0 square, u square plus 2 minus at the time of projection, u is upward, g is downward, minus 2g h max. Why I'm making here h max? Because at h max only the zero velocity. Here at that position will be the h max. So that I need to find h max. U as already found as 0, u as g by 2, t1 plus t2. Clear? Whole square is that u square whole square minus 2g h max. Clear? And when elaborating this, this is 0 equal to g squared by 4 t1 square plus t2 square plus 2 t1 t2 and minus 2g h max. Clear? H max equal to 2g h max equal to g squared by 4 of just like that t1 plus t2 the whole square. Just leave that g squared is right side. So here g is cancelled, g squared cancel, g is cancelled, and then 2 h max equal to g by 8 t1 plus t2 the whole square. There is no need of expansion of this t1 plus t2 whole square. So simply h max is equal to g upon 8 into t1 plus t2. Clearly we can understand. So that there is maximum height reached by the body. And one more thing is velocity at h by 2. Velocity at h by 2. V squared equal to u squared minus 2g h1. This is equation 1, any equation. This is any equation, either that equation we can select, and for that h1 we need to put v squared u squared minus 2g h by 2. V squared equal to g by 2 into t1 plus t2 the whole square minus 2g h by 2. And then what is height is already found. Height is g squared by 4 t1 plus t2 the whole square minus 2g. For that h we can have h, what is h? H is half g t1 t2, half g t1 t2. Just put it half g t1 t2 by 2. Then we have a final formula g t1 plus t2 the whole square minus this 2 cancel each other. Then g squared t1 g squared by 2 t1 into t2. This is the final form. And expanding this and cancelling all the things, expanding what is that g squared by 4 and t1 plus t2, the expansion form will be g squared by 4 t1 square plus T2 square plus 2 T1 plus T1 into T2 whole square minus G squared by 2 T1 T2. Then just when multiplying inside, there is a two portion. You will get what is that when multiplying inside? When multiplying inside, G squared by 4 into T1 plus T2 square. Then multiplying this inside, G squared by 4 into 2 T1 T2. Then what is this two cancel each other, cancel one times here, two times. Then already remaining things is G squared by 2 T1 T2. Clearly we have that this whole term and this whole term cancel each other because similar. Then the remaining will be G squared by 4 of T1 plus T2 square close bracket. This will be the answer, V square. So what is V? When we take other side root. So taking other side root, V equal to G by 2 under root of T1 square plus T2 square. This is velocity at the position of h by 2. At the position of h by 2, the velocity will be v. So this is we need to understand about the kinematics given in the sum. The problem state the body is projected vertically upward at the time t1 ascending, at the time t2 descending. The what is the height above the point of projection. So everything we did and found the answer. Okay, thank you all of you.